Welcome to Mechanical Sati. So today we'll start a new session, new lecture series that is based on MCQs for SSCJ. So first subject we have considered that is thermodynamics. Sorry. Without wasting time, let's start it. So first question, it is given nitrogen at an initial state. So pressure P1, B1 and temperature T1 is given, and it is expanded isothermally to a final volume. So B2 is also given. So PBT relation is given, and it is telling that A is greater than 0. So A will be always positive. So it is telling that it is isothermal expansion process. So this term will become constant totally because temperature is given constant here, and R is the universal gas constant. So I can write this term at state 1. This term at state 1 will be equal to this term at state 2. So I can write P1 plus A by B1 square whole into V1, that will be equal to P2 plus A by B2 square whole into B2. So I need to find out P2. So P2 will be equal to what? P1 V1 divided by V2 plus I can write A by V1 into this V2. So V1 by V2 minus I can write A by V2 square. So here P1 is given 10 megapascal, sorry 10 bar. Okay, so 10 into V1 is 1 divided by V2 is 2 plus I can write A1 by V1 into V2. So A1 divided by V1 is 1 and V2 is 2. So that will be 2 minus A1 by V2 square. So that will be 4. So directly I can write 10. This will be 5 plus A by 4. So this will be equal to 5 plus A1 by 4. Sorry, A by 4. And here A is given as positive value. So this term totally, that is P2, will be always greater than 5. So here option B will be always correct. So next, so the PP diagram has been obtained from a test on a reciprocating compressor. So which of the following represents the diagram? Okay, so for reciprocating compressor, the initial to suction and after compression, so your pressure will be higher and lower. So initial to suction, your pressure will be minimum, and after compression the pressure will be maximum. So this is the point, or this is the diagram. So your D option will be correct. Then next question, so which of the four figures have been drawn with respect to a fixed thermodynamic cycle? Okay, so according to first law of thermodynamics, equal areas enclosed by. Okay, so in case of your figure 1, so this is a clockwise cycle, so this can be a cycle, and again figure 2 is also clockwise cycle, but figure 3, if we'll see, so in this it is telling that this is clockwise, and in this it is telling that anti-clockwise, so this cannot be a cycle. Likewise also figure 4 cannot be a cycle. So we can write answer figure 1 and figure 2 satisfies the condition. So here A option is correct. So next of the following type. So here E is told as your heat, and F is told as your work. So heat when added to a system, it will be positive. So E after G. So okay, EG. So this option is cancelled. Then this is an inexact differential, EGJ. So this option is also cancelled. This option is also cancelled. So B is the right, sorry, this is D. So D is the right answer. Then next, 100 kilowatt bulb was switched on in this area or this volume, you can say size the insulated room. So our dq is equal to 0. So okay, so insulated condition. Then room having temperature, so initial temperature is given T1, I can say T1 equal to 20 degree. Okay, the final room temperature will be what at the end of 24 hour. So after 24 hour, what will be the final temperature of that room? Okay, so first it is given sorry 100 watt bulb, so I can find out how much amount of heat is going to dissipated by that bulb in 24 hours. So that can be calculated. Q equal to P into T, where P is the power that is given to us. Okay, so Q can be calculated, that will equal to 100 watt. Okay, so into in 24 hour, T for time, that is 24 into, I can multiply with 3600. So this much heat, that is we can find out in terms of joule, we can find out the heat. Okay, next we need to calculate the final temperature of that room. Okay, so if we can calculate in terms of temperature that amount of heat, so Q will be equal to what, that is mc dt. Okay, so m we can say that will the amount of mass of air which is present inside that room. So I can find out that by using rho into V. Rho is the density of air and V is the volume of air. Okay, and 2 C is the specific heat of air and dt. So that will be Tf minus Ti, where Ti is known to us and Tf we need to calculate. And if we compute with Q, so Q we have already calculated from the power concept. Okay, so rho is 1.2. okay, rho of air is 1.2 and V we can calculate by multiplying these 3. Then C is 1.005. okay, and Tf we need to calculate it. So Tf minus Ti is given 20. That will be equal to this heat what we have calculated before. So from this, if you can calculate, so you can get the value. So 341 approximately B will be the answer here. So I am not calculating, so you can calculate this value, you can get this answer. Then next, the above cycle represented on TS plane by this one. Okay, so this is the PV diagram is given and we need to calculate, we need to find out the corresponding TS diagram. So you see here 1 to 2 is a constant pressure process and 2 to 3 is a constant volume process and 3 to 1 is a constant entropy process, isentropy process you can say. So 3 to 1 is a isentropy process, so these two get cancelled and this among these two one may be my answer. Okay, and see, this is a clockwise cycle and if we can see, then this is not a clockwise cycle, this is anti-clockwise cycle, so this will be my answer. So C is the correct option here. Next, so in a steady state flow process taking in a steady flow process taking place in a device which in a single inlet and single outlet, the work done per unit mass flow rate W equal to this much. Then where V is specific pressure, then the expression W where it can be applied. Okay, so I can write from the first law of thermodynamics, del Q will be equal to du plus del W. Okay, and if we'll be neglecting kinetic energy and potential energy for a steady state process, steady flow process, I can write del Q will be equal to dH plus del W. Okay, So if I need to calculate this dH value, okay, so for H will be equal to what? H equal to U plus PV, okay, and if I want to calculate dH, that will be equal to dH plus PdV minus VdP, okay. If so, that will be du here, du plus PdV minus VdP, okay. So if I will put this du value here, so I can find out dq will be equal to what? dH minus PdV minus VdP. So I can write dH minus PdV minus VdP plus dW, that is del W. I can write PdV. So PdV and PdV can get cancelled. So from here I can write del Q will be equal to dH minus VdP, okay. So dq is this much, that is dH minus VdP, and here we know dq equal to dH plus del W. So I can write these two equations. So del Q equal to dH plus del W, and del Q equal to dH minus VdP. So now if we combine these two equations, then I can ds can be cancelled. So del W will be equal to minus VdP. So if we integrate, then I can get VdP minus from 1 to 2. So from this equation we can say that this is valid for any reversible process, okay. So this equation is valid for any reversible process. So option will be correct option will be C. Then next, so a balloon containing ideal gas is initially kept in a evaporated and insulated. So insulated means that will be del Q will be equal to 0 here, okay. And the balloon ruptures and the gas fills up the entire room, okay. So this is again the condition of what, that is a free expansion. So del W will be equal to 0 also. Then which of the following statement is true? So from the first law of thermodynamics, del Q will be equal to du plus del W. If this is equal to 0, then this is equal to 0, then du will be also equal to 0. So it is indicating that it is not changing, so no change in internal energy. So next thing also we can say, so in this process your enthalpy also remains constant, because whatever, so H equal to U plus PV, so dH equal to du plus VdV plus VdP, okay. So if this is 0, and we can say there is a change in pressure and volume, but they change such a way that the multiplication of PV remains constant. So dH is also equal to 0. So here correct option will be C again. So both internal energy and enthalpy of the gas remains constant. Then next, a compressor undergoes a reversible steady process. Okay, the gas at inlet and outlet of 1 to pressure and PO. So already we have discussed this type problem. So specific work to be supplied. So work done by system will be equal to minus VdP 1 to 2. So it will be supplied, so minus will be cancelled, so B will be the correct answer. Next, A frictionless piston device contains a gas initially P1 and V1 is given here, and it expands quasi-statically at constant temperature. Temperature remains constant. Then final volume V2 is also given. Then the work output. So for isothermal process, okay, where did it go? Okay, so for isothermal process, W will be equal to what? P1 V1 ln V2 by V1. So here P1 is given 0.8 into V1 is given 0.015 and ln 0.03 divided by 0.015, so it will be 2. So ln 2 is will be equal to 0.69. So if we multiply, you can get this value, that is 8.32 kilojoule. So here the answer will be option number A, 8.32 kilojoule. Okay. So next, if a closed system is undergoing an irreversible process, the entropy of the system will be increased. Okay. So for any irreversible process, entropy must increase. Okay. So normally, according to classical statement, entropy change ds, what happen? It may increase or equal to 0. So for isothermal process, for reversible process it will be equal to 0, and for irreversible process it will be greater than 0. Okay. Then come the following statement: heat source 1200 Kelvin losses 2500 Kelvin. Okay, at sink temperature is 800 Kelvin. Second heat source 800 Kelvin, and the sink temperature is 500 Kelvin. So which statement is true? First, okay, so you have to check the irreversibility here. So for irreversibility, we can check the entropy. Okay, so I can write down. So from the classical statement, we know that if dq by t is less than 0, then this is irreversible process. Okay, irreversible process. Okay, so we need to calculate dq by t. So first one is your q1, that is 2500 by 1200 minus 2500 by 800. So you can calculate this value. So this will be 2.083 minus I can write 3.125, so that will be equal to 1.92. So minus 1.92 something. Okay, likewise you can calculate for next process. So next process I can write 200,000 by 800 minus 2000 by 500. So you can get this value 2.5. okay, 2.5 minus 4. Okay, so here you can get minus 1.5. okay, so process 2 is more irreversible because dq by t is greater than dq by 2. Process 2 is greater than dq by t for process 1. So you can tell that process 2 is more irreversible. Okay, so process 2 is more irreversible, so option B will be the right answer here. Then next, a monoatomic gas, so gamma is given here. Then molecular weight m is equal to 40 given. Then compressed adiabatically from 0.1 megapascal temperature is given to pressure 0.2 megapascal. The universal gas R is given. The work of compression, okay, So for adiabatic process, I can find out the work done by, so W equal to P1 V1 minus P2 V2 divided by gamma minus 1. Okay, where P1 is given here and P2 is also given here. Okay, P1 P2 given, but P is not given and T is given, so we need to convert this into in terms of T1. So I can write M RT1 minus M RT2 divided by gamma minus 1. If we take common MR here, so I can write MR T1 minus T2 divided by gamma minus 1. So if we can calculate M and R, and T1 is given, if we can calculate T2, then we can calculate W. So but here is given asking find out the work of compression of the gas in kilojoule per kg. So we can take this M into this side, so I can write W equal to W by M equal to R T1 minus T2 divided by gamma minus 1. Okay, so for finding R, I can write R equal to what? Universal gas constant R bar divided by M. So R bar is given 8.314 divided by M is given 40. So I can calculate this value. So already I calculate that value. So R bar will be equal to 0.208 value. Okay, so next I need to calculate the temperature T2. So this is a adiabatic process, so adiabatic relations can be used. So T2 by T1 will be equal to what? P2 by P1 whole to the power gamma minus 1 by gamma. Okay, so P2 is given 0.2 and P1 is given 0.1 whole to the power gamma is 1.67 minus 1 divided by 1.67. It will be okay. If you want to calculate T2, then T1 will be multiplied here, so it will multiply by 300. So from here, if we calculate, I can calculate that value. So T2 will be equal to what? 396.3 Kelvin. Okay, so T2 and R is calculated, then I can put to directly into that equation. So W by M will be equal to what? That will be 0.208 into 300 minus 396.3 divided by 0.67. So I can calculate that value. It will be come out by 29.7 kilojoule per kg. So to check that value, calculate and find out this value. So here we can get this value as 29.7 kilojoule per kg. Next, 1 kilogram of water at room temperature is brought into contact with high temperature thermal reservoir. So entropy change of the universe will always positive, we can say. So change of entropy change of universe, that will be del S system plus del S surrounding. So entropy of universe will be always increasing. Okay, so here D option will be correct. Then next question, a turbocharged 4-stroke direct injection diesel engine has a displacement volume, so Vs displacement volume or sweep volume, that is given 0. This value. Okay, the ending output, so P is given power 950 kilowatt. 950 kilowatt and N is given 2200 rpm, and we need to calculate the mean effective pressure. Okay, So for calculating power in case of your engine, we know that is P. Okay, let me change. Okay, so P equal to, that is P M L A N K, okay, divided by 60, where Pm is the mean effective pressure, L is the stroke length, L is the cross-sectional area, N is the speed, and K is the number of cylinder, you can say, and is the 60. Okay, so everything is given here. We need to calculate N here, or N, that is, or K, number of cylinder will be equal to what, 1 by 2 here, because it is a 4-stroke engine. So K will be replaced by 1 by 2, and everything is given, and LA multiplication of cross-sectional area and stroke length, we can calculate Vs. Okay, so Pm will be equal to power, that is 950 into 10 to the power 3, okay, into 60 divided by, okay, then PML and the Bs, that is 0.0259, B into that is speed 2200, okay, and here 1 by 2 it will go up, so here we can get the value as 2 into 10 to the power 6 Pascal, which will be equal to 2 megapascal. So here the option will be option number A is the right answer. Okay, so A here. Then next, the values of enthalpy of steam at inlet and outlet of a steam turbine in a Rankine cycle. Okay, so if I will to draw the Rankine cycle, it will be somewhat like this. Okay, it will be somewhat like this. So this will be 1, 2, 3, 4. We did the TS diagram. Okay, so H3 and H4 are given. H3 equal to what, 2800, and H4 equal to 1800, and it is telling to calculate the neglect the pump work, and we need to calculate the specific steam consumption. Okay, okay, where did it go? Okay, so okay, this one. So H3 H4 is given, so from here I can calculate the net work done. So W will be equal to H3 minus H4, so it will be 2800 minus 1800, so that it will be equal to 1300, that is kilojoule per kg. Okay, next I need to calculate the SSC, that is specific steam consumption, that will be equal to 3600 divided by 1000, so I can get this value as 3.6. So 3.6, option A will be the answer. Then moving towards next, the crank radius of a single, so R is given just 60 mm, and diameter D is given, diameter of the cylinder is given 80 mm, and the swept volume we need to calculate Bs. So Bs, so it equal to pi by 4 d square into L. Okay, D is given, we need to calculate the stroke length. So stroke length will be equal to 2 into crank radius R. So I can calculate 2 into 60, that will be equal to 120. So you can put that value, pi by 4 into d square, that is 80 square into 120. So calculate, it will be in terms of mmq, and we need to convert that mmq into centimeter cube. So we can get this value 603, that is 603 centimeter cube. Calculate and find out. So here option D will be the correct answer. Then next, the contents of wall insulated. Okay, so insulated means dq will be equal to 0. Okay, then where did it go? Okay, so q equal to 0. Then it is resistance R is given 23 ohm, and A is given current, sorry, I is given 10 ampere. Currently consider consider the tank along which contains thermodynamic system. Okay, the work done by the system and heat transfer taken as positive, heat transfer to the system taken as positive. The rate of Q, W and D you need to calculate. Okay, so electrical work is given here, so W can be calculated as, that is I square R. Okay, so I is 10, so it will be 100, it will multiplied with 23, so it will be 2300 joule. Okay, so in terms of kilojoule it will be 2.3, and it is given to the system, so it will be minus, so minus 2.3 kilojoule. Okay, W will be equal to minus 2.3. So if W equal to minus 2.3, then dq equal to dE or dU plus dW, and if this is 0, then it will be opposite to this dW, so this will be the answer A. So here Q is equal to 0, W equal to minus 2.3 and Q equal to positive 2.3. So option A is the answer here. Then next question. An ideal gas mass m and temperature T1 undergoes a reversible isothermal process. Initial stage P1, final stage P2. Then what is the entropy change? Okay, so we need to calculate the entropy change here. So we know from the first law dq. Okay, so dq equal to du plus pdb. Okay, so if we'll replace this p, we know that pv equal to mrt. Okay, I can write p as mrt by b. Okay, so if I will write this p in terms of this one, then I can write, okay, so under dq I can replace by tds, that will be equal to, under du will be what, m cb dt. Okay, plus p will be replaced by mrt by v into db. Okay, so here this is a isothermal process, so this term will be equal to 0, and here t can be cancelled, so now I can write, okay, let me go to next page. Okay, so ds will be equal to what, that is mr, okay, dv by v. Okay, it will integrate from 1 to 2, because these two are constant. Okay, so I can find out that will be equal to mr ln v2 by v1. Okay, and here it is not given in terms of volume, so we need to convert this into in terms of pressure. Okay, and for the isothermal process pv equal to constant, so I can write p1 v1 will be equal to p2 v2. So I can write p2 by v1 equal to p1 by p2. So our answer will be mr ln p1 by p2. Okay, so your answer will be option number B, mr ln p1 by p2. Then moving to next question and the last question. A cylinder contains 5 meter cube of an ideal gas at a pressure of 1 bar, and the gas is compressed in a reversible isothermal process till it pressure raised to 5 bar. Okay, so work required. So Eg already we have done this type of calculation. W equal to what? P1 B1 ln P2 by P1. So everything is given here. P1 is 1, P2 is 5 into ln P2 by P1, that will be okay 5 by 1. So this will be ln 5 and multiply. So you can calculate. This will be equal to 8.047 joule. Okay, so the options are given wrong here, so it will be 8.04 joule. Okay, so it is asking in terms of kilojoule, so answer will be 8.04 into 10 to the power minus 3 kilojoule. Okay, so with this we have completed 20 questions today. So next onwards we'll continue another 20 questions. Okay, so thank you.